Hey, it's Hawken with TopDon. Today we're going to take you through a diagnosis we performed on a 2017 Dodge Durango. This vehicle has the 3.6-liter Pentastar engine and an all-wheel drive powertrain. We're going to go ahead and walk you through the diagnosis. The concern was a no crank, no start, and we did diagnosis recently here just in May. So we're going to walk you through all the steps we took in order to figure out what was wrong with this vehicle, and we're going to show you the tools that we used in order to diagnose this problem. So today we used the TopDon oscilloscope in conjunction with our TopDon Phoenix Lite 3. The two of them are compatible, of course. We used our TopDon Phoenix Lite 3 for live data analysis, as well as oscilloscope functions. The oscilloscope for our oscilloscope function, which you'll see a video of one of the tests that we performed with the oscilloscope just a little bit later here. We also used our new TopDon 120 amp power supply and battery charger. Now we use the 120 amp power supply and battery charger to not only recharge the battery of the vehicle, we also used it as a stable power supply during our diagnostic process to make sure that the battery voltage did not become a factor in diagnosing the concern. Couple of additional tools we used in this video. We used a current clamp, a 30 amp DC current clamp. We used a relay control breakout device with a current loop, which is referred to as the AES Wave U Activate, and we'll show you how we use that in a video. And then we also used service information. Of course, we cannot diagnose a concern without the appropriate wiring diagrams and information on how the system works. So we also had access to that. Just wanted to say a special thank you to Mike with 710 Diagnostics and Repair in Boscobel, Wisconsin, for working together on this video with us and allowing us to record and show you all of this information so that you can learn from the diagnosis. So our initial concern with the vehicle was a no crank, no start. The vehicle was towed in on a flatbed, and because it was on a flatbed, the vehicle had been placed in a neutral position so that it could be properly moved onto the flatbed without damaging the drivetrain. So we are going to have to remedy that first before we do any diagnosis. The customer reports that they had recently installed a starter on this vehicle, and they said that the vehicle did start once and then it never started again after that. Again, it does look like this vehicle may have been sitting for some period of time, potentially in a barn or something of that nature. So we just want to keep that in the back of our mind as we go through this. So the first thing I do, and most of my friends who do a lot of diagnostics typically are going to make sure the 12-volt electrical system is in good shape. So we're going to connect our T120A and we're going to recharge the battery first. Then we're going to place the T120A in power supply mode so we have stable voltage throughout our diagnosis, including our pre-scan. So we're going to go ahead and show you how we connected that up and the pre-scan that we performed. Okay, in this video, we're going to connect our TopDon T120A to the vehicle. We've already recharged the battery using the T120A. Now we're going to place it in supply mode, and we're going to perform a pre-scan. So you can see we're in supply mode here, 13.6 volts steady, and we are drawing, it looks like about 39 amps at the moment. And we've got it connected to the appropriate terminals here up on the vehicle. And we've got our dongle inside the vehicle connected to the DLC data link connector. We're just going to make sure we don't have any updates that are necessary here. We're working on a Dodge, so we're just looking for Dodge updates. There's no Dodge updates, so we're going to hit auto scan, and we're going to go ahead and scan the vehicle. Now, pre-scans are always a good step in your diagnosis. Makes a lot of sense to invest your time doing this, not only for protection of your shop or yourself as an individual, but also just for making sure that there are no additional issues created throughout your diagnosis and testing.
So we're just going to do the pre-scan here. And of course, as always, it's really smart to have good, strong internet access when you're doing any diagnostics with the tool, just to ensure that you have the latest and greatest information and the greatest accuracy of what the software finds for fault codes and live data. So as you can see, the scan goes pretty quickly here. And we will show you the results of the scan up on the screen here in just a moment.
Okay, so here's the results of our pre-scan. Obviously, you probably couldn't see that on the screen, so we're going to show you here on the screen now. So you can see we do have a variety of faults. Now remember, this is the first scan we did on the vehicle before we did anything else. So I always like to do a pre-scan before I touch the vehicle and remedy any faults, including putting the transmission back in park. And then I like to make sure the battery's all the way recharged and then put it in stable voltage supply mode on our T120A, clear our faults, and then see what faults come back. So again, this is before we cleared any faults. And of course, we do see some faults for the transmission not being in park position. And if we look at the rest of our faults, we do have a couple of U codes. Now remember, U codes may result as a reason because of low battery voltage. So if we have a bunch of U codes or even a few U codes, we want to recharge that 12-volt battery first and verify to see if any of those U codes actually come back. Then, after we've recharged the battery and we have it in power supply mode, we have to try and duplicate the symptom again and see if those U codes come back. If they do not come back, but our symptom is still present, which was the case here, then we know that those U codes are not going to be a factor in causing our symptom to occur. So again, we mentioned this vehicle appears to have been sitting for quite a period of time. That may be because they replaced the starter and thought they had it fixed and didn't. It may be for a variety of other reasons. You never really know. But we recharged the battery and we put it in power supply mode on the T120A, and then we did our pre-scan. And so we've remedied all of that, and none of the faults came back that could have anything to do with the no start. The U codes were gone, and also the transmission park position codes were also gone. So nothing that would prohibit this vehicle from cranking or starting came back in any of the modules. So we know now that there's nothing that the computer systems are aware of that should be inhibiting this vehicle from starting. So now we need to take a look at a few other things in order to figure out why this vehicle is not cranking or starting. So we're going to take a look at the wiring diagram for the system here, and we're going to show you what the wiring diagram looks like and explain how the system works. So the starting circuit, we have to remember that all components require power and ground in order to function. That includes the starter motor. Now, the starter motor has two power feeds. There is a constant power feed and a switched power feed. So we'll show you how those are set up here in the wiring diagram. The main power feed to the jump post or remote jump post, as we see up here in the top center of the wiring diagram or top right, that power feed comes directly from the battery. So that is not a switched power, that is a constant power. That goes to the remote jump post junction, travels through a fuse, and then goes out to the other places that it feeds, including the switched power side of the starter and the constant power side of the starter. So we'll show you here in the diagrams in more detail. So on the left-hand diagram here, this is the switched power side, which goes to the solenoid of the starter, right here. And then on the right-hand diagram, we have the constant power feed to the starter. The constant power feed, they don't draw the wiring all the way from end to end. They show a little jump here, but that goes directly from the battery, so that is a constant power. The left-hand one is a switched power. That switched power gets switched through two different relays. So now we need to look at the relays and how those are controlled. So the relays, relay 1 is controlled here by the body control module. Relay 2 is controlled by the powertrain control module. So we know both of these two systems have to control a relay in order for the vehicle to start. we were able to verify that the command was happening from both of these modules to ground these relays. We have no fault codes. And on many Chryslers, as mentioned by Mike at 710 Diagnostics, because there is a ignition crank sensing wire, you can often view the cranking status in live data of the PCM. Now, we did not get a video of this, unfortunately, so I would love to show you, but we were able to verify that this vehicle was grounding the relays for these two. But what we don't know is if the wire that goes from here, this junction block, down to the starter solenoid, we don't know if that wire is intact. So how are we going to verify that power is actually getting to the starter solenoid? We need to figure that out. So what we're going to do, we're going to move my little bubble to the bottom right here so you can read this. So we know nothing is prohibiting the vehicle from cranking. We verified that. We have no codes that are inhibiting cranking. We can verify that the powertrain control module and the BCM are attempting to ground the relays. We do not know if current is flowing from the junction block to the starter solenoid. So we don't know if the starter solenoid is receiving power and attempting to crank the starter. So we're going to install a relay control bypass in place of the second relay. Then we're going to install a current clamp on the breakout loop. Then we're going to activate the starter solenoid relay with our bypass. And we're going to crank the engine using either the key or push button, depending on what system your vehicle has. And then we're going to see if the engine will crank. We're going to monitor and see if there's any current flow from the junction block to the starter control solenoid. If there is current flow, then we know the wiring is intact. And of course, we want to look at how much current flow. We would expect somewhere between, well, we could look at our fuse and make a reasonable determination that it's a 30 amp fuse feeding that side of the circuit, or a 40 amp fuse, pardon me. So it is possible that we could have anywhere between 10 and 25-ish amps, most likely. But if we have somewhere in that range between roughly 10 and 25 amps going to the starter solenoid, then it's reasonable to conclude that the wiring is intact. So we're going to show you that test in our video now. But we're also going to show you real quick here where we put the bypass. So here is the bypass. We replaced this relay with the bypass. And then again, we're going to monitor the current flow on this yellow and green wire to see if we have current flow when we try to crank the engine and we close this relay deliberately on our own. And the only reason we're removing the relay is so we can monitor current flow using the breakout of the UActivate tool.
Okay, so we're going to walk you through our test we did here. Again, we've got the relay breakout installed in place of the relay so that we can manually command on the relay, and this should cause the vehicle to crank if we turn the key at the same time. So we're going to go ahead and show you the video here. So we've got the scope wired up. You can see the flashing light indicates it's connected. We've got our current clamp around the current loop that's on the relay breakout. We've got our scope set up here, and we'll show you here as we zoom in, just so you can see the screen. We're going to command the relay on, and immediately we can see that we get current flow going to the starter solenoid. That indicates that we have a complete circuit to the starter solenoid. We're getting roughly about 10 amps or 11 amps or so. We'll see when we refocus the video here. So you can see maximum current flow is about 11 amps. And the starter solenoid should be cranking the engine. However, it's not. So a simple quick test we can do with the scope and that relay bypass.
So we proved that there was flow of current to the starter solenoid. We know that the starter is still not cranking. Now, we could go back to our wiring diagram and watch the flow of current on this starter relay output circuit, which is actually a constant power feed, and we could see if any current is flowing on this wire when we try to crank the engine. However, the starter's not moving. So we don't know if there's going to be any current flow or not. Now, we could also access the starter and take a visual look at the starter to verify that the starter is in fact connected. Might be important, right? Maybe the main power feed is not connected. We may also want to investigate visually because we know the history on this vehicle indicates that somebody has been in here before. So we probably want to take a look visually if possible. Now, if there's a problem with the block ground that feeds the starter, remember all components have to have power and ground, we could easily run a jumper cable from battery negative to the engine block or to the starter case to verify if the starter is not getting a good ground. Now, as far as the main power feed, the one that we cannot verify as easily, we could also run a jumper cable of a large thick gauge directly to that post on the starter where the big thick wire goes from battery positive in order to verify that it's not a wiring problem there as well. Now, another thing we want to make sure we do is verify that this engine is not seized. If the engine is seized, the engine's not going to crank. So we're going to want to get an extension bar in a socket, and we're going to want to put that on the crankshaft bolt and try to rotate the engine clockwise to verify that the engine is not seized. Once we've done that and proven that the engine is not seized, we can feel confident that that's not a factor in the starter failing to crank the engine, correct? Yes. So we did perform a visual inspection, and I'll move my little bubble back to the bottom left so you can see. And what we're looking at here in our pictures, the top big picture here is the starter. Now, we could see this underneath the vehicle with a borescope, or if we moved the engine around or if we moved the vehicle up on the hoist and we walked around underneath, we can actually see most of this from underneath the vehicle. So this is why a visual inspection has so much value. We could see a lot of black char kind of in the vicinity of the starter, and we could see that our main power feed to the starter was still there. Unfortunately, we had some evidence that the magic smoke, as we like to call it, has been let out of this starter, and that there was some char and some melting that appeared to have happened. We could also see, you see on the main feed here that it looks kind of black and charred. This is your constant power feed lug right here, and many of the connections were not particularly tight. Now, if we look over on the bottom right here, you can see that that's the main feed. The eyelet there is the main feed for the starter, and that eyelet shows a lot of char and blackened kind of appearance. That's usually an indication that maybe some arcing had happened. The connections were not tight to the starter, and when you have loose connections, that will create arcing, and it can create some of that black char. That's going to make it difficult for current to flow if there is not a good connection. The control solenoid connection was also melted, and you can see that wire there is physically broken in this picture on the bottom right. So this vehicle is going to need a repair of those two wiring connections. So clean off this and potentially replace as needed. And then we're going to have to replace the control solenoid connection as well in order to ensure we have clean, tight connections, and we're going to need a new starter. So again, walking through what we've done so far, we verified we had current flow to the starter control solenoid. We also verified that the relays could all closed and the engine is attempting to crank over. We also verified that the engine was not seized mechanically. So once we did all this and then we performed our visual inspection, we could clearly see that the starter was at least part of the problem. We also saw that the connections were at least part of the problem. So we're going to need to remedy that first, put a new starter in this vehicle, fix our connections, make sure they are clean and tight, and then retest the vehicle as needed. We'll move our bubble back to the bottom right so you can see everything again here. So again, here's our summary of what we found and what we needed to do. So again, we're going to make sure that we replace that starter with a new quality unit. We're going to clean all the connections that can be restored and make sure they're tight on the new starter. We're going to replace that starter solenoid connection, the small plastic connector. We're going to replace that and make sure that's clean and tight to the new starter. And then we're going to make sure our starter is properly bolted into the engine block. And then we're going to retest the vehicle. Now, the bad news here. We did perform all of those repairs. We installed a new starter. We cleaned all the connections and replaced the starter solenoid connector. And the vehicle did crank and it started and ran. Unfortunately, after it started and ran, we discovered that this vehicle appears to have a head gasket failure. There was some white smoke coming out of the tailpipe, and it does appear that this vehicle has a mechanical engine failure. Now, when an engine does not crank or run, we can't really prove this out in advance. So, unfortunately, this is a bad news scenario. We resolved the primary concern of the customer by replacing the starter, cleaning the connections, and replacing the starter solenoid connector. However, there is an additional problem with the vehicle that will prohibit the customer from driving the vehicle further, uh, even though we have resolved the starting problem. So we were able to resolve the problem using our test equipment here, and you can see how we were able to use the Phoenix Lite 3 and the oscilloscope to verify that current flow to the starter solenoid. And you saw how we use the T120A to set up as a power supply and properly do our battery charging as well as our pre-scan of the vehicle. So hopefully you found this video useful and you learned something. If you appreciated the video, please like, subscribe, comment, and share. And as always, we really appreciate you taking the time to watch our videos. So again, I'm Hawken with TopDon, and thanks again for watching.